Is it past midnight yet? Who knows? Time is relative, as you'll soon see. A step into time dilation. So, time dilation is famous for Einstein, but this is a guy called James Clerk Maxwell. Everyone already knows Einstein, so we're getting this guy's story. Imagine you're in a car or something and you have a baseball. If I throw that baseball, let's say at 5 kilometers a second, to me that baseball looks like it's traveling at 5 kilometers a second. Now, if I'm traveling in my car at an extra 3 kilometers a second, then to him it looks like the ball is coming out at 8 kilometers a second. This makes sense, it's fairly intuitive. The issue, and what this guy discovered, is what happens when you apply it to light. We're going to have to up the scales here, so imagine you're in a spaceship. Let's say you're going at 50,000 kilometers a second, and you turn on a flashlight. I think the speed of light is like 300,000 kilometers a second. So for you, since you're moving, you see it going out at 300 kilometers a second. Same with our baseball, it's just going out at a much faster speed. Let's say you have a guy resting on another planet. If he sees you turn on that light, for him, he's going to see the light travel at the same speed you do. And that makes no sense. That's like if I throw a baseball at 5 kilometers a second and I'm moving at 3 kilometers a second and someone is sitting and watches the baseball get thrown at 5 kilometers a second. It doesn't make sense. The really cool thing that Einstein does, we're going to move on from this guy and go into Einstein's work now, is he's able to rationalize these two things. Imagine we have two mirrors next to each other. We've spaced these two mirrors 1 meter apart. We have a beam of light going up and down. Now, the time it takes for the light is 2 meters, because it has to go up and down, divided by the speed of light. We're going to call it not moving TS. What happens if we are moving? Well, doesn't that kind of look like the Pythagorean theorem? Well, first of all, we just have L, which is 1 meter, it's going up. And now we have CT, which is basically the speed of light going that way. And we have VT, which is basically how much we've moved. Let's just plug that into the Pythagorean theorem. So what we did here is we isolated for capital T. Now, there's an issue here. Capital T is just going up. But remember, we need both up and back down. So for our total moving frame of reference, Tm is going to be equal to 2 capital T. For now, let's focus on this equation we have right here. Because to get T equal to Tm, we need to multiply everything by 2. So that gives us this brand new equation. Now, in my mind, this is the hard part to realize because literally all we've done so far is simple algebra and simple geometry. So he pulled c squared out of this and he wrote it up here. Does this look familiar to you? If we go all the way back here, it's our formula for the stationary time. So what Einstein just proved is that your time moving depends on your velocity compared to your time stationary. But this has a lot of cool implications that I think people have to learn when it's kind of very obvious from the formula. Your time depends on how quick you're moving. And we never notice it because the speed of light is so stinking fast that this fraction right here is basically 0 all the time. So what's 1 minus 0? 1. What's the square root of 1? 1. What's anything divided by 1? Itself. So in most cases, this is equal to this. Unless you're dealing with some crazy fast speeds like near a black hole, in which case time changes. Now the fun thing is you can basically use this equation for anything. Like if I jumped across this room, I could calculate the velocity of that, and I could run the time dilation. It'll come out to almost 0, but I could do it. It's not that hard. Look at it. This is a simple equation. Can you tell that it's past midnight? Have I been losing my mind? It's been 30 minutes. I've been filming for 30 minutes. This kind of shows us why we can't go at the speed of light. So imagine we go at the speed of light. So our velocity is c. C squared divided by c squared is 1. So it's 1 minus 1, 0, 0. Square root of 0 is 0. But then we're dividing by 0, and it just breaks. And we can get to E equals mc squared from this, which is another reason why Einstein's famous, but it is very late, and that is much harder. So if this video gets tons of support, maybe I'll do it.